Hello everyone, my name is Ben Eady and I'm an online media manager for ModernAnalyst.com, the premier online community for business analysts. I'd like to welcome you to today's webinar titled Rapid Analytics, a visual live approach to requirements gathering and business analytic development. Today's featured speaker is Mark Marinelli of the VP of Product Management with Lavastorm Analytics. The webinar will last approximately 16 minutes, including the Q&A session. So make sure to submit your questions in advance using the question feature of the webinar software. And I'd also like to say thank you to Lavastorm Analytics for sponsoring this event. And at this time, I'd like to turn it over to Mark to get us started.
Thank you. Hello, everyone. Thanks for joining. My name is Mark Marinelli. I'm the Vice President of Product Management here at Lavastorm Analytics. I'll be taking you through a combination of presentation material and a demonstration under the headline of Rapid Analytics. As said, a visual live alternative approach to requirements gathering and business analytic development. The agenda for this webinar is basically I'm going to start talking about why traditional analytics projects fail. We're talking about an alternative to these projects, so first we need to diagnose the problem. Next, I'll talk definitionally, what is rapid analytics, what sort of techniques are applied, how is it different from traditional analytics, and what sort of software tools would enable this new technique. Then I will show a demonstration of Lavastorm software, which was really purpose-built for this approach, and it'll introduce or animate some of those techniques that I talk about. Next, we'll talk about how rapid analytics has opportunities in the business. Where would you apply this technique and contrast to traditional analytics approaches? Then we'll have a conclusion and question and answer period. So as said before, please save your questions and answers, questions for the end, and I will, after I've gotten to the conclusion, we'll spend as much time as we can addressing them. Before I get into the material about rapid analytics, I want to tell a little bit about who's telling the story. A little bit about Lavastorm Analytics here. We're a company who gives enterprises a new, agile way to analyze, optimize, and control their data and processes. We've been around for about 15 years. We've got thousands of users at 80-plus customers. We've created billions of dollars in customer value, and we have a global presence, major offices in the U.S., the U.K., and Asia-Pac, about 120 of us. Our software, we're a software company that makes business analysts heroes by giving them the power of a programmer to rapidly unify disparate data sources, to easily construct complex analytics using those data sources, and to effectively deliver actionable insights and results from those analytics. And as you can see here, we've got an array of customers from across geographies, from across industry verticals, and in different types of segments or customers and partners. And we've gotten a few awards over the years for the performance that we've allowed our customers to achieve. So I'll start with the elephant in the room. What's the problem? According to Gartner, 70 to 80% of corporate BI projects fail. That's a pretty large amount. Failure can be defined a lot of different ways. Sometimes the project was just untenable. Sometimes the relevant data sources, the relevant opportunities in the business could not be uncovered and the project was shut down. Sometimes the project completes, but you don't get uptake. You don't get the uptake from the consumers of the BI project, the consumers of the analysis that are expected, because it is too cumbersome, because the information is not useful. There's a lot of different ways to define the failure of this, but we're seeing the overwhelming majority for Gartner as failing. Why? The main course of failure is a lack of understanding in the real requirements of the analytic project. You've got sort of a chicken and egg situation where in order to build an application, you need the right requirements. In order to discover the real requirements, you often have to have an application running, and only with contact with the data and the problem areas are you going to tease out a lot of those requirements which are really found along the way and which were not known ahead of time. there's problems in the business, a poor communication between the IT and the business users that can introduce a lot of friction in this requirements to application development process, meaning that the business users, when they ask questions of the IT department, are often not speaking the same language, that they cannot particularly identify the table in the database that they need in the format that they need it in order to satisfy some question they ask of the business, because they're not down in the IT structure. Conversely, the IT audience can sometimes be very well aware of the organization of the data, but not the implications for the business. So it's difficult for them to have that shared view of how the analysis is performed to tease out the right requirements, both from a data and from a business rules and analytics perspective. So a failure to ask the right questions, or to be able to ask the right questions, mixed with a failure to think about real needs of the business, what's really the outcome of gathering all of these data and performing these analysis, is to collectively you see a sort of breakdown operationally, which will end up getting the wrong results or not getting any results at all out of one of these projects. So traditional approach is BI. We've satisfied some of the analytic problems in the business using business intelligence, where we have operational data are warehoused in relational databases or cubes, and they're controlled by the IT brokers and go through the typical waterfall approach of requirements, design, implementation, verification, and maintenance of the final product. That's traditionally the way an analytic application is brought to market or internally. These bring dashboards and reports, but these dashboards and reports are often answering predetermined questions. There needs to be more insight outside of those predetermined questions in order to get at a lot of the unknowns in a business. And BI is really better tailored to a line of inquiry which is known ahead of time, and minor variants thereof. It provides analysis of highly modeled and cleansed data. That's a good thing. The data have been cleansed, data integrity is ensured, and the models lend themselves to rapid iterations of those predetermined questions, the ability to drill down in several levels of detail. That's a great facility that BI provides. The problem is that the limited predetermined drill paths are somewhat narrowing, and in order to get outside of those guardrails, you have to ask complex questions of the data using complex query tools, which are often really only useful for technologists, people who have a certain conceptual understanding of how the data are stored and how things like hypercubes work, are going to be a much more limited audience or a set of contributors to the analysis than you'd like. It's all subject to IT development and governance. So it's great that you have brokers of the data and a centralized set of brokers of the data who are going to ensure that data integrity, but you're putting yourself in a single point of failure there, or a single point of throttling the ability to get new analyses, new reports out to users. So BI, of course, it's what we've been doing for a long time. It has its applications, but it's really limited. It's best applied where stability reigns, where the data sources, the set of data available to the analysts and the requirements of those analysts don't change very much. They're stable processes that are not all that variable. The data are well known and well controlled. As I said, these are warehouse data sources. They're brokered by IT departments, but they're internal data. They're data that can be controlled internally versus having to get data from external sources, public sources, external systems, etc. Technologists are answering most of the questions. The end users are able to iterate on those questions and slice and dice their data to change a pie chart to a bar chart and drill down, and certainly they can ask variants of those questions, but it's really left in the purview of the technologist to set up that infrastructure. And IT owns all of the source data. That's if IT can actually get their hands on all of the data, own it, be the brokers of it, then BI is fine. This falls down when you have a set of sort of under-the-desk databases that people have to track their own areas of the business that really, they're not all identified. It's not easy to warehouse them. It's not easy to make a business case to warehouse them. But if the data can all really be centralized, then traditional BI approach is going to work. Problem is that, especially in recent years, things have changed to the point where the strengths of traditional BI are really strained. We're outside of that. Businesses are completing more on analytics. There is a need to differentiate based on competitive advantages that are uncovered through analytics. The speed with which you can adjust to new market pressures, new customer demands, the accuracy with which you can assess those factors, and the visibility that you can give to all of the relevant areas of your business is really crucial to being able to create those competitive advantages that stem from analytics rather than other vectors or new investment. There's also a new set of customer expectations. Their customers are expecting that they're going to have a personalized experience, that you're going to know what movies they want to watch or what purchases they want to make. That requires a lot of data, a varied set of data, and a lot of people working with the data. Big data adds another area here where we've got new large volumes of data. There are more systems and machines and people producing larger volumes of very varied data than we've seen in the past. And these data arrive and change at a higher velocity than traditional data sets. So that means we have to have more tools to deal with different types of data, and we need to be able to incorporate those new data and large volumes of data into our set. That is going to be difficult through a traditional single lens of a BI infrastructure. And there's just more complexity overall. And there's an increased reliance on outsourced providers of business services, for example, Salesforce for CRM. That produces the type of need to incorporate externally housed data for critical business operations. You've got fractured value chains from order to cash. It presents numerous points of friction where a holistic view of the business is desired, but each individual organization that touches a customer through that value chain is going to have difficulty exchanging data or having the same view of that activity than the next set. So all of those together conspire really to test the boundaries of traditional BI and require a fundamentally new and different approach. Not a replacement, but a new alternative. That's where rapid analytics comes in. It's a new approach. It requires different techniques, and it requires new technologies. Essentially, it's a new methodology. There's an emphasis on rapid prototypes, not traditional specifications. So instead of the very front-loaded process of gathering all of the requirements, identifying all of the data that are going to be necessary to perform an analysis, we start working with what we can get our hands on and prototype it, and then iterate and iterate and iterate. We'll add more data, we'll add more business rules, but we don't want to be trapped in that upfront, very front-loaded process where we're not going to start producing value or answers until we've answered every possible question that we could ask. There's also an emphasis on direct business and user interactions. rather than using documentation, rather than using a sequence of emails and documents and meetings to work between the IT group and the business group. Optimally, you want to do these things in real time together. If you've got the right technology, you can have a more direct conversation between the subject matter expertise, subject matter experts who are going to really know the areas of the business you're trying to analyze and the data in them, and the more technically inclined folks who are probably going to implement many of the analyses. Optimally, those two people become one if you give them the right tools. There's also an emphasis on responsiveness and reactions. It's really, again, not that front-loaded. We need to identify every data source we're going to need and every question we're going to ask before and build a bunch of infrastructure. Rather, let's figure it out as we go along. Let's be able to respond to what we find in the data rather than trying to a priori figure out every permutation of what it is we'd be looking for. So that methodology, very agile methodology, requires new technologies. Requires technologies that enable self-service BI, that enable satellite groups to acquire data and work with the data rather than being beholden to the centralized brokers of the data. It requires data discovery technologies that allow you to work with a subset of the data to discover that you have an imperfect or incomplete rule set in the analysis or an imperfect or incomplete data set in the analysis and rapidly incorporate improvements on both the rules and the data. And the mashups, being able to bring in various types of data which independently would not answer the question, but when put together, end up producing more than the sum of their parts. The technology should be data-driven, not schema-driven, meaning that you should be interacting directly with the raw data rather than imposing an overarching schema and a model to rework the data. You should be able to get the data in quickly, work with the detail level data as it is, and maybe later on build some more complex models, but not be hamstrung up front or constrained by having to build a lot of infrastructure. You also need the data are going to arrive in complex, disparate, and dissimilar packages. They're going to be data from multiple different sources, maybe the same data that are rendered different ways in different data sources, and they're going to be complex. There's not going to be one single flat file that provides the universal answers. There's going to be data in many different places that needs to be combined. So I'm going to show a demonstration pretty soon of one of the tools and show some of that methodology being employed. I'll talk a little bit about this technology before I show it. It's really the Lavastorm Analytics Engine is the core software offering that I'll be showing today, and it combines three very important different technologies that are used when we're trying to have this agile approach. One is ETL. I need to be able to, in an agile fashion, pull in data from myriad data sources. I need to be able to not only grab the data, but I need to emulate some of the data integrity checks, cleansing and such, that would be available to me through a warehouse without having to build a warehouse. That's part of the self-sufficiency, is being able to emulate rather than rely upon a data warehouse. I need BI. I need the ability to visualize the data. I need the ability to automate the things that I'm doing, like a BI tool will offer a monthly, daily report. I need to be able to do that too. I don't want a tool that's simply going to allow me to ask one ad hoc question, however interesting and complex it would be. I need this to be a process in my business. And a 5GL approach. The more you want to democratize the ability for people to perform these analyses, you need to give them tools that allow them to work in an intuitive fashion with the data. That does not mean SQL scripting, however well documented it's going to be. It means a more visual, object-oriented way of modeling the business rules, of building these sorts of analyses, and of communicating to others what they mean. So that said, I'm going to bring us into the software now in a second. Before I do that, I just want to frame the problem. The particular application that I will be showing you was built to solve a problem. It's a rather simplified version of the problem, but I need to frame it a little bit so you have context to what I'm going to show. In our scenario, we have a telecommunications operator. And believe it or not, their goal is that everyone who is consuming any of their services gets billed for it. An analysis is necessary to find out where that's not the case. And it can happen in that fractured value chain in the telecommunications industry or any other, where you're moving from a customer placing an order to you provisioning their product or service, to that order ending up on a bill and actually sending out the bill. There's a lot that can go wrong there. So you really need an analysis of several different data sources to determine where those customers who aren't being billed exist. And once you find them, optimally find out why they're not there so that you can correct them. You can correct them on a one-off basis and to have a systemic correction where there are infirmities in the process by which these customers should be being billed. Challenges to do this are diverse data sets. You've got a whole, in this particular example, this operator had multiple acquisitions of other businesses over the years. So that leaves them with a mix of multiple billing systems where they're trying to bill these customers, and a heterogeneous network where they have all manner of different network components that are servicing these customers that all speak a different language. None of the relevant data sources in this scenario are warehoused. But the good news is that extracts from the relevant systems are produced for other purposes. So we're going to repurpose them for our analysis. And here, there was no visibility into the problem so far, so there's no business case to consolidate the data sources into the enterprise data warehouse. So again, we're at the chicken and egg here. If I can't tell you that I know that there's a problem and I know it's a $2 million problem, I'm going to be pretty low on the list when others are waiting for their data to be added to that enterprise data warehouse that may sit behind all of the analytic infrastructure in the company. And here we also have a small team there that is going to research and correct the errors that we find. So we can't waste time on false positives. This needs to be an accurate and comprehensive analysis so that no one's chasing ghosts. So that has framed the problem, and now we're moving over to the Lavastorm analytics engine, the front end of the technology that I'm going to be showing you. Before I get into building out the analysis, which I've just described, I'm starting you off really at the end here of the end state of the analytic application built with the technology as a way to really introduce you to some of the different areas of the software and some of the language that I'll be using as you see me build this thing more from tabula rasa. So essentially, the Lavastorm analytics engine is a visual tool for creating analytic models, such as you see here, and applying those analytic models to the relevant data sources from the systems attendant to the process we're analyzing. If the software can be used to provide a model of business rules that represent how things should be working, and the data, which definitely represent how things are working, if we can bring those two together and apply the rules to the data, we can determine where there's fallout, where there are exception cases to those rules that are going to require correction, and will be the actionable results of this analysis that we're looking for. This model is comprised of a sequence of steps. You see me go from left to right, and I'll be using these steps as I build the model in front of you. We have to acquire data. We have to prepare our data for our analysis. We have to perform an analysis. And then after we've discovered where those infirmities in the process are, where those exception cases are, we want to quantify them and categorize them so that we can optimize the reconciliation of the problems that we find. So that when I publish in the last step out to reports or case management tools or CRM systems, I'm not only telling you that I've got 100 customers who are not being billed here, I'm telling you that the top 20 in terms of the services that they're actually consuming that they're not being billed for, so that we can approach those first versus the folks that may be just dripping away and potentially costing the business $1 a month. The nodes themselves, each one that you see here, is an incremental step of the process of a business rule. So we have nodes for data acquisition on the left. You can see me on the bottom of the screen scrolling through the palette of nodes that ship with the core product. They're organized by different functions. So there are data acquisition nodes. There are aggregation and transformation nodes for altering the data set, very similar to really a full suite of ETL functionality. There's correlation nodes to look for where data are matching or where they should match, both in a discrete sense and also employing fuzzy matching techniques. We've got inflow reporting nodes here. As you can see, one of them is off on the right of the screen for doing analysis, visual analysis right in there, along with the others. And then there's a set of interfaces for external systems and other nodes for changing the structure of the data, for looking for patterns in the data, for publishing data out to external systems. When I build this application, I'm actually building it with the live data. So I'll re-execute a couple of these nodes that you see here. It happened pretty quickly, but the predecessor data sets were brought in. They were processed by the node, which implemented a business rule such as filter out the customers who have voicemail in this system, and produced an output. The output of 607 records can then immediately be interrogated within the application. You'll see me do that a bit as we go through and build this application. So those are the piece parts, and this is really the final product. This is an application which takes the billing and network data. The network data is where my 1,000 customer services are, and the billing data is where hopefully 1,000 of those 1,000 customers are being billed, and brings in some other data sources to help categorize the data, but ends up producing a list of these 131 customers who are not following the rules. Not their fault, ours, but they are not being billed for the services that they're consuming. So I'll go back in time, and where did we start? Where did we start? What sort of requirements did we start with? What sort of data sets did we start with? How do I get from almost tabula rasa, or a very limited understanding of what I need to do to solve this problem, all the way to that final end state? I've skipped a few steps here, just in the limited time that we have, but what we've done is started off at acquiring the billing and network data using the acquisition capabilities of the software. Acquiring the billing data, acquiring any data source is a drag and drop operation. My billing data source here is a combination of a database query and a flat file, and if I drill inside it, we'll see that it's built to pull in a subset of data. I've only got 12,000 records here, but it's got a toggle here where I can switch over to pull out of the enterprise data warehouse in the event that these data end up being there, or I can pull out of some other production system. So I can switch from a sample data set using existing file extracts to an operational data store on the fly, but my logic downstream is going to be the same. The ability for me to very quickly acquire these data, it's wonderful, but one of the limitations it imposes on me is that I'm not going to get the data in the clean fashion that I would get it if I were working in a prepared data store or a data universe. So the first thing that I really need to do before I get too far along this path is to ensure that I have data integrity. I have to emulate some of that functionality, looking for gaps in the data, looking for duplicate data sets, doing anything like that if what I'm going to do on my own is going to be useful. So the first thing you'll see me do here is pull in a duplicate detection node, set it up to my network data. As we see here, we've just got a list of telephone numbers and the type of service that's on that telephone number. I'm going to choose one of the fields in there, a telephone number. I'm going to look for duplicate telephone numbers in the data set. All right, that's good news. I've got 1,000 records. I have no duplicates. On the billing side, let's make sure that I've got all of the data that I need. So I'm going to pull in another node called an interval inspection node. And I'm going to hook that up to the billing data. And what I'm looking for here is there any record ID? Is there any gap in the record IDs of this data that indicates that I'm missing data? If I pull up the data and you can see here there's a record ID column, I want to make sure that it's all there. I'll execute that node and I'll see, well, sure enough, there is a gap. There's a gap of 401 records in the data set. That means that I'm going to have to go back and get some more data in order for me to have a really holistic view here, because if I'm telling my business downstream here that I've got 223 unbilled customers and I'm missing 400 billing records, there's certainly a potential for error there. We don't want to go out and start calling people and asking them to pay their bill if it's our fault because we just didn't have the data. So that's our first set, and it's sort of under the rubric of self-service BI, is being able to acquire data quickly and to emulate some of that data hygiene practice that we would get from a more core broker of the data in the business. So now that I've brought in my data, we're going to table our data integrity issues for now, but I've brought in my data, and so I've got my switch data and my network data and my billing data, and I've done a little bit here just to prepare the data. I started off with 12,000 records in the billing set, but they weren't organized the way that I needed to have them, so I aggregated them here, and I did, again, that emulating some of the functionality that not just in data integrity, but also in the data preparation that you would get from a traditional BI infrastructure. I'm doing that here. And then I'm comparing them. I'm using one of my correlation nodes to perform a correlation between these based upon that telephone number, and it's producing three outputs. The 9,000 some odd records in the billing system that aren't in the network. That makes sense. I've got more billing data than network data. The 777 that I have in common, but really importantly, the 223 from this network side for which I have no billing data. I'm not going to stop there, though. The thing if I take this set of 223 unbilled customers, I don't really have enough information about them to say anything more than that they're unbilled. So I brought in some other data, usage data. Is anyone actually using this service? And I brought in some rate data based upon the different system services that are provisioned on this particular account. And I'm going to use that to estimate a financial impact. So that's good. I've got 223 customers. I can tell you who could, if we could get that into a paying customer, they'd be worth $20 a month versus $80 a month. But I still don't really know anything about why they're not being billed. I just know that that's not happening. So optimally, I would bring in something about the orders that were placed. When this customer came in and placed their order, and then they were added to our network, something happened potentially that stopped them from ending up in the billing system. That's one cause of error. So again, I'm going to drag and drop in here an order data set. This is just another file extract that's out on my system. I'm going to execute that. So now we have 7,000 records from the ordering system, 7,000 some odd records. and I'm going to combine them with my network data. So I have an enriched data set. So I'll move these guys off down there, and I'm going to use just a lookup here. Put the network in there. For the order data, I'm going to look up based upon they have to have some sort of common key. If I look at the data, I see that there's a telephone number on both sides. Pick those fields, execute my node. So now I've got 1,000 records, and instead of just having a telephone number and service type, I've got a telephone number, service type, and a whole bunch of ordering data. I'm now going to replace the data set that was going into my analysis with this newly enriched set. Re-execute my analysis because my data need to be refreshed. And now let's see if I can find something interesting about this data set now that I've got a bit more about who's not paying. I'm going to take a look and see if when we look at those fields here, what could we look, maybe the contract date or the order date. It'd be interesting to know. In this scenario, we had a system outage a few weeks back. It'd be interesting to know if there's any clustering of the issues that we find here that could have been attributed to that ordering system outage versus if we found a concentration of these issues that were related to a specific person in our ordering department. They suggest different root causes. Now, I'll pause here and say I didn't start this knowing that I was going to be looking at that. Only by going through, finding that I actually had a problem, finding that I had these 223 unbilled customers, did I know that I should continue and go further. So I introduced a requirement for more data. I satisfied that requirement for more data by quickly adding all of those data. And now I'm going to extend my requirements to find out what patterns I can find in the data. So I'm going to use the status date field here and run a histogram. And let's see how that turns out. Well, I already knew the answer, but it's pretty interesting here that out of that errant population, well over half of them don't even have a status date in the order management system. That could be that system outage. And then there's another day, and this is pretty well spread across 2003 or 2006, but there's just one day where a pretty outsized subset of the data of these unbilled data were ordered. So that suggests to me another avenue of inquiry. I think I want to take a look at that at some point and figure out if the root cause is that system outage or something else. A system outage is probably not something I can do all that much to repair, but as I said before, if the alternate root cause were a set of customer service representatives in my ordering department, that's something I can fix. Having the tools to make that determination gives me a lot of interesting opportunities to fix things. So the next thing we do, we'll do it in our mind's eye right now, is to finish processing these data and send them out to the team that's going to correct them. So I've given them a bit more information. I've told them about how much it's worth to the business to fix. They go off and they start fixing them, and they come back to me and they start complaining because I keep giving them, in this 223, this population of customers, I keep giving them phone numbers that are our numbers. They're, the telecommunications operator itself has a whole bunch of test lines that they use to make sure that the network is functioning properly. They're obviously not going to bill themselves for them, but they're in this network population and they're really polluting my data set. So what I need to do there, yet another requirement, but this is a requirement not to find where the answers are, but to hone the analysis that I'm only producing accurate answers. Another requirement is for me to bring in a list of these internal lines. Again, I'm just using one of my acquisition nodes here. It's a file that was provided to me by the IT department. Now I'm going to bring those in and I'm going to remove them from this analysis. use a correlation node here, and I'm going to take these 500 and remove however many of them are in the main population. Again, I'm going to do it based upon the telephone number. All right, 110 of them have been removed from my source population. Now I have a ripple effect where I can connect this new data set, re-execute my analysis, and well, that's a big improvement, a marked improvement. I've removed 100 of those errors that I was getting. So you've seen me do some of this incrementally. I'll bring us back where we began. You'll see that there's a few more things that I had to do. There's another couple of exception cases. I'm applying some fuzzy matching to find some areas where the number was just miskeyed by somebody hitting the wrong digit, but it's actually really in the billing system. There's numerous other rules that I'm able to apply. But as you can see, we did this in real time. I'm building this in front of you. If I'm a technical user of our software and you are a subject matter expert or a business analyst in the business and you know all of these rules, I become a stenographer of those business rules, and we are in real time. We're gathering those requirements. You tell me what we need to do next. We implement those requirements. We validate those requirements by looking at the data that results from each individual step, and we document the requirements. I now have not just a chapter and verse document which describes what I did, which may not actually be in concert with the technological implementation of the rules. I've got it all in one pretty intuitive graphical format here. It's very easy for me to now explain to someone else in the business the steps that we took for the analysis. And more importantly, it's very easy for me to augment this. If we find that we've got a variant of these exception rules that I just showed you, and we want to model those, I just copied and pasted my data here. I'm going to my nodes. I move them over here. Let's say we make some sort of change, and then I execute that line. We can see if that produces a different outcome. We can see if we discover new rules now that we didn't even know, or maybe it's a blind alley and we go back to the main analysis. But because we've been encouraged to pursue some of these hypotheses outside of the narrow set of questions that we started with, we can be sure that we've done a more comprehensive job of looking at the problem, and thus our results are going to be more accurate. Lastly, when those results are produced and somewhere down the line someone wants to know where they came from, I have the tools to trace back through all of the different business rules, all of the things that I did to the data, all of the requirements that I gathered and implemented, so I can take you all the way back to the source data to find out where that single telephone number that I told you need to fix, where did that come from? So that concludes the technology demonstration portion, but I'll just come back here and recap. What did we see? We saw that there's a technique here of incremental discovery-based analysis. In real time, in a collaborative fashion, if I weren't just collaborating with myself there, we've done the requirements gathering, the implementation, and the validation process using a pretty intuitive visual tool. It's really an optimal way to do this rapid analytics. We've got accurate answers in seconds. In a few minutes, I was able to build a few things, and in a few seconds, I can try variants on those different questions that I've asked of the data. I tested the business rules with live data, and I applied validations and improvements to my logic in real time. And again, that low cost in terms of time and effort application of hypotheses to the data encourages the search for those exception cases, those edge cases, which often account for a lot of the reasons why the process is infirm. That spreadsheet that's on Susie's desk that has a list of customers that we never quite got into the billing system, I want to be able to pull that in very quickly, add it to my data set. That's not going to happen if I have to go through the traditional data warehousing or data broker. Rapid data acquisition. I pulled in some data. I started off with a couple of data sets that were outside of the warehouse, but I was still able to bring them in, and then I added new data as I needed it. I didn't have to use intermediaries to extract the data for me. I didn't have to impose a structured schema on all the data. I didn't have to build dimensions or drill paths or anything like that to the data. I just brought it in and started working with it. And I didn't have to warehouse the data. I may warehouse the data sometime in the future. I still can use all of this logic on that warehouse data because I'm able to toggle back and forth between the way I got the data and the way I might get it in the future, but I'm not dependent. So really, that self-sufficient data federation, that ability to build a virtual warehouse and to analyze it, frees you from the constraints of traditional data warehousing. I can manipulate, I can prepare the data sets, I can change field names, and I can parse out fields, I can homogenize data sets. I can do that all within the same tool, so I'm kind of independent from data brokers. I may need them to get the raw data, but I don't need them to prepare the data the way that I want it for my analysis. But I still have the tools for making sure that whatever it is that I do to the data, I ensure data integrity. I make sure that my rules and my data manipulations are just so that I don't pollute the downstream analysis. So I've spoken about a specific example using our software. I'll talk a little bit about some success cases or anecdotes that we'd share from our experience using this Agile approach over the last few years. With new data sources, we had one communication service provider who had spent 400 hours, man-hours, trying to get at a problem with no results because, as I stated way up front, they couldn't ask the right questions from the technology group, and the technology group didn't know enough about what they were trying to do to give them the right data. In 3 days, using the software that I showed you and having the right people in the room and a few different data sets that we were able to cobble together, we were able to emulate on their false start and improve upon it to actually have a working application within a few days. That collaborative approach, using as many data sources as you can cobble together, can have a dramatic accelerant on time to productivity. And responsiveness. There's a quote from one of our marquee customers saying he can get the information when he's in the middle of a conversation with somebody. So you don't have that interval of ask a question, someone goes off in a dark room and builds you some software and gives you an answer that may or may not be right because you didn't ask the question quite the right way. That responsiveness, that real-time collaborative relationship is something that CenturyLink, Tom there, has certainly leveraged well. And there's more visibility that the overarching analytic footprint grows because you're going from ignoring information because you can't make a business case to get it in the warehouse to uncovering, in this case with a particular CPG company, tens of millions of dollars of lost revenue. They couldn't even start to quantify the problem because they couldn't get the right data. When they used our tool and some of the proxy data sources that were available to them, we were able to build a quick analysis and extrapolate from that millions, tens of millions of dollars of lost revenue. This slide that just says that the stuff that I'm talking about, the rapid analytics, there's opportunities for this all over the business because there's all these friction points between and that order to cash chain that I'm talking about, between yourself and your customers, between yourself and your partners. It can be tremendously expensive to build infrastructure to service some of the analytic needs at these boundaries. It can be a lot cheaper and a lot faster and much more, a much shorter interval time to productivity when you leverage an Agile approach. And we're not displacing BI. This is an alternative, we think, superior approach for a lot of problem areas, but it's not a displacement. We're not going to throw out our data warehouse. We're not going to throw out our BI tools and our nice reporting portals or anything like that. But we can use these technologies to augment them, to supplement them with other analyses, or to build ahead of time. We can build something quickly, agilely, find enough of a business case based upon what we find there to get ourselves at the top of that list for the BI projects, or really to satisfy any sort of business case for putting more people or technology at the problem. So what does it all mean? In conclusion, the rapid analytics that I've talked about and that I've shown you, it's an entirely different experience for IT and for the consumers of the information. It's enabled by new technology that's complementary to traditional BI. From the user experience, you end up with analytic applications, not just the report, not just the answer that you can manipulate in a limited fashion, but the whole application end to end that you can drill into. It's a gray box, not a black one, where you can drill in and add new data sources, implement new requirements. Relevant data are all in one place. You're building sort of a virtual federated warehouse of data on the fly, allowing many different consumers of those data, whether those data reside in the company, outside the company, in the cloud, they can all be brought together. Real-time updates, when things change, as they always do, you can change those rules, you can change those data sets and produce new results. Of course, those changes are expected. And it's really designed for business users, a visual sort of 5GL type environment. You're not going to be writing Java code or even SQL script. If you know your way around something like Excel, then you've got the skills to use a tool like this, or the right set of tools will enable that user to be productive. From the IT side, the data foundation to support Agile BI is built through light mapping, not a heavy modeling exercise or warehousing or building cubes or data universes or anything like that. You're just mapping the data, and you can work with the data in raw form and get it the way you want it to be pretty quickly. You work with the data as is. There's no cleansing from their perspective, because some of the cleansing can be taken on by those self-sufficient analysts. And the whole time you're collaborating with the business, you're using a shared visual tableau so that you're talking the same language, that you can look at the data, you can look at the logic attendant to a process together and hone that. So in summary, really, opportunities for this approach, they're all around and all across the business. Anywhere where speed matters, where the ability to get answers quickly to complex problems, you're going to want to apply this technique. That ends the presentation and demonstration portion of the webinar. I think I've got some questions here. I'd like to take them. I've got a question that says, this tool is like Oracle, but you don't write any SQL code. You just use these ready things like lookup, analyzing the situation by using the data. Yes. It's not magic. You're going to have to give the technology some direction. As you saw, when I want to look up two data sets and even do a complex join where I do the left inner and outer join, I still need to signify which of the individual fields I need to join on, but I'm not sitting there and pounding out SQL. For the majority of the things that I'm doing, I'm really drag, drop, and drop in a couple of field names. Does Lavastorm work well? The question is, does Lavastorm work well with web analytics as well, or mostly flat files and database structures? Our software is essentially, it was designed to deal with structured data sources. If we have facilities in the software to call web services. You saw me only working with file-based data sources, or I've had an emulation there of a database file source, database data source. But we can also pull in data from web services. So we can call right out to Google Analytics, or we can call out to a GIS system or Salesforce, pull in those data. The data themselves are going to have to be structured, but we can incorporate those along with other types of data sets into the types of analysis that I talked about. And where that breaks down, where we're dealing with more exotic formats, if we're using a non-traditional database, or if we're using semi-structured data, we can integrate with other technologies we can call them out using our interfaces and adapters. We can call them out, have them transform the data into the structured format that we need, and bring it in and incorporate it alongside the other formats. Are there any risks? The question is, are there any risks associated with rapid analytics? Well, you certainly, I think any self-respecting IT technology person would say, well, there's a risk in giving these data sets to people and not having control over how the data have been cleansed and warehoused. And that's why I talked a bit about the onus being on the Agile analytics, the rapid analytics user, to make sure that they choose a technology that provides the tools necessary to do some of that data cleansing themselves. You don't want everybody out with satellite databases, sort of misinterpreting the core data set and building answers based upon it. So you want to at least provide them the tools and the guidance from an operational perspective to ensure that they work that into their methodology, and they're going off essentially the same sheet of paper as everybody else. Another question, how will the software perform with large data sets, such as 10 data sets with 2+ million records each? Well, working on my pretty old and not so great laptop, you saw me working with tens of thousands of records. That's really the beginning of it. Our software scales up tremendously. There is a range of different configurations of our software, from a free Windows-based desktop to a more high-powered desktop, to full-blown server application where you can deploy it on a cluster of many machines. We have customers who are working with large volumes of transactional data in the billions of rows of data sets per day. So we really scale with as much hardware as you want to throw at the problem. Another question, you have limited tools regarding correlation, acquisition, etc. Is it possible to build inside the program more tools for calculations if necessary? Yes, and that's where our interfaces, that class of nodes, we have interfaces for popular programming languages like Java and Python. So if you've already got a program that's out doing something with the data, well, just use our software to call that program, but then bring the return data set back in with the rest of the data you're using in Lavastorm. We also have a native interface to the R computation and statistics language, which provides itself a wealth of high-order analytics, predictive analytics, some more interesting correlation functions than the discrete and fuzzy matching that we provide. And that allows you, if you have an R environment, to take your R script, put it in one of our nodes, execute that node, have the job run on the R server, but receive Lavastorm treated data in return and incorporate it with the rest of the data. Another question, do you find that IT is having trouble presenting analytic information to the business decision makers? I feel that a lot of analytics tools use a set of terms that common managers and executives cannot decipher. What is an effective way of solving this problem? Well, I think part of it, when I talked at the end of the demo, I talked about documenting the problem with the software. Part of the problem is that you're introducing a layer of abstraction when you have a document, and then you have the code that implements the document, and you have the data that the code worked on. If you can pull that all together and put it in a logical picture, an executive can walk in the room. An executive could watch this webinar tomorrow and pretty easily understand what I did. And if he needed to ask a whole bunch of questions, it would be easy for me to drill in as a technologist, to drill in and explain to him, a business user, and answer all the questions as they came up. I think that's all the time that we have. So I'm going to end the Q&A portion. I thank everyone again for attending. And as you see on the final slide here, I'd encourage everyone to go download the free version of our software at the URL there. And if you have any questions, we've got a lot of contact information here. So please reach out to us, and we'll answer them as best we can.
Thank you, Mark, for a very informative presentation, and thank you, everyone, for attending today's Modern Analyst webinar sponsored by Lavastorm Analytics. I wanted to point out the webinar along with slides will be archived at ModernAnalyst.com within a few days. And this concludes today's event. We hope you have a great day.